So each of you are making just one triangle, and then we're going to talk about those, okay? Any triangle you want. Be as creative as you want to be. Go.
Just one?
Yeah. Just one. Oh, and Brooklyn's already done. Yes, it is.
It's really easy.
Perfect. Keep that right there. Okay, and then when you're done, just kind of move your bag out of the way and put your triangle in front of you. Oh yeah, good. These guys are awesome. Okay. Everybody has a triangle? Okay, go ahead and stop right there. Today what we're going to talk about is how, or actually tomorrow what we're going to talk about is how to name or classify the different types of triangles. Because we could say, well, these are all triangles, but that's not very descriptive because when I look at Hosea's triangle, that looks really different than Caden's triangle. Those are very, very different looking shapes, aren't they? Okay, and that looks really different than Brooklyn's.
It's the wrong way.
Okay? Oh, and maybe she has it going this way.
No, side.
Like this?
Yeah.
Okay, so this triangle is also really different than these ones, so we have to be a little bit more descriptive. Mathematicians use really descriptive words to talk about the shapes that they're working with so that other people can visualize them. I'm noticing the rubber bands are becoming a little bit of a distraction. I want to see your eyes. Thanks. If your rubber bands are a distraction, do we need to put them just away for right now? Okay, you're good? Just don't touch them. All right, so I have some words that are hopefully going to remind you of the number corner that we talked about way back in November. I have some words. Mathematicians have, just a minute, with our geoboards, they're down in front of you. We're going to talk about those in just a second. Be patient. They have talked about triangles by thinking about their side lengths, okay? Like triangles that have three sides that are all the same length, those are called equilateral triangles. Okay? And they've also seen that some triangles, some of you made triangles just now, where two of the sides are the same length, but one of the sides is different. And those they've called isosceles. Are these words ringing a bell?
Yes.
Oh, I'm so glad.
In 4th grade.
And then there's another really weird word that is kind of a tricky one for kids to remember a lot of times that talks about when all the sides are different lengths. And that word, scaling. Isn't that a funny sounding word? Everybody say scaling. Scaling. Okay. There's those word resource cards. So if we were to look at our triangles right now, we could give them a name based on their side lengths. So I want you to take a look at yours. Take a look at your triangle. How many of the sides are the same length? Are any of them the same length? I'm going to have you try on a little sentence frame here. Sentence frame is the same one we used back in November for number corner. The triangle is blank because, oopsies. The triangle is equilateral because it has, what would I say? How many equal sides does it? 3 equal sides. Or let's do it for isosceles. The triangle, everybody together. The triangle is
isosceles because it has 2 equal sides.
okay, let's try it on for scaling. The triangle is
Scaling because it has 0 equal sides.
okay, so the first way that we name a triangle is by side lengths. I want you to practice showing and telling your partner what kind of a triangle you made on your geoboard. Turn and talk. talk, yeah, Caden and Jacob, you guys talk, you two. Yep, good. What do we have?
I made an
Oh, do you mean, so you're actually measuring? Did you guys hear what she said? Could you say it one more time so that they can repeat you?
This is just a
So why would that be isosceles? Manila, looking at hers. Why would hers be isosceles then? Two sides are equal. Valeria, what kind of a triangle did you make? How many sides are equal? Are 3 equal, or 2 equal, or none? Three. Okay, can you guys help her use the sentence frame? All right. Let me check really quick. There's a lot of things in this lesson, so I'm just gonna glance and make sure I remember what we're doing here. Okay, yep, I do. Okay, so I would like you guys to practice sharing about your triangles. Would anybody be brave enough to try? You can use the sentence frame, or if you want, you can describe it in your own way, but the sentence frame might be helpful for the beginning. Okay. Daniela, can you come on up and hold your, yeah, here, I'll hold it for you. Needs a piece of white paper behind it. Thanks, Kaden. Oh, you're not getting it? Never mind. No, thank you, Kaden. Okay, I want you to be able to see her triangle. Okay. Daniela, tell us about your triangle. And everybody needs to have their hands free right now. And where should your bodies turn? There you go.
The triangle on this last week has 2 equal sides.
Show us what you mean.
These 2 are equal and this is a bit longer than this.
Could somebody repeat what she said and why?
She
Wait,
said,
Brooklyn, is everybody listening to?
she said that the triangle is isosceles because there are 2 sides that are equal and one is a bit longer.
Okay. One is a bit longer. Thank you. I want us to think about Hosea's. Hosea, did you classify yours? Hosea's is just so different than most of yours. Everybody take a look at this, and I want you to think about what you might hear Hosea say. I'm gonna wait for everybody's eyes over here. You wanna give it a try? Barely hear Hosea. Let's listen again to him. Nice and loud. Somebody repeat that even louder. Jane?
Is that his triangle is scaling because it has 0 equal sides?
Do you guys agree with that? Why? Oh, you don't agree with it?
I kind of think it might be an isosceles.
It's a bit longer, but it's
Okay, so Jacob is saying that he thinks, let's go ahead and open this up for discussion here. So that means our hands are free and we're gonna listen to each other's arguments and try and help each other decide if this is scaling, all sides are different, or isosceles, 2 of the sides are the same. And Jacob, could you take a seat on the carpet, please? Can you call on somebody to support or disagree with you?
Well,
that one's longer than the other.
Which one? Can you point? Do you think this one is a little bit longer than this one? Okay. Could you look around and call on somebody?
I don't think that's real because it's just more stretched out. That doesn't mean it's actually longer, it's just a little bit more pushed away. Like if we got a ruler and measured how long each one was, I bet it would come out to be the same. That one's just more stretched out that way.
Okay. Jacob, what should you do right now? Wait, Brooklyn, wait for everybody.
It's longer because it's at a tilt. If it was straight up, it would be isosceles. But both of them
The
Will should see which one is longer and what one.
Okay, you think you're not gonna be quite convinced until there's a ruler. A couple kids behind you are wanting to build on what you guys are saying, it sounds like.
Like mine's just smaller, but I literally put my fingers on it and then I went over here and it's like almost one longer. It's not quite exactly, so that's why it might confuse people because you look at the dots and try to use it.
Okay. And you know what, this is a really tricky one, isn't it? And what Jacob is noticing is that these two side lengths look like they might be the same. And other kids are saying, well, this one actually looks to me like it's more stretched out, which would make it longer. So should we measure it really quick just to be sure?
Yes.
Okay. Jacob, why don't you come over here and help me measure?
I think that's 8 inches.
Inches?
Yeah.
How many inches?
7.
7 on that side.
7 and 1. Like 7 and 1 4.
Okay. And how much is this side?
7 and 3/4.
So one side was 7 1/4, one side was 7 3/4. So what do you think?
This side is longer. This side looks more stretched out when it's shorter.
Oh, this side was the longer one.
Probably 2
Yeah.
pounds.
Okay, go ahead and take a seat. So what kind of a triangle is this, everyone?
Scaling.
Scaling. So we've seen a scaling triangle and we have an isosceles triangle. Does anybody have an equilateral triangle? Or something that looks equilateral? Because I don't know if we can get it exact on these geoboards. Okay, Elizabeth, let's see. Okay, Elizabeth has this one. What do you guys think? Is it equilateral?
Yeah.
Okay, raise your hand if you also have an equilateral. Can everybody hold up the equilateral triangles? Hold them up, nice and big. Okay. Okay, lovely. All right, that brings us to the next thing. So just because we've classified them by their side lengths, doesn't mean we're done. We also have to look at because some triangles, like this isosceles triangle, who else had an isosceles triangle? Can I mess with yours?
Yeah.
This isosceles triangle, right, 2 equal sides, and this isosceles triangle, 2 equal sides, are still really different, even though they have the name isosceles. So we also have to get even more specific. Whose are those?
That was mine.
Take it back, and stop touching your rubber bands, seriously. So now we have to look at the size of the angles. So there are triangles that have right angles. Those are called right triangles. There are triangles that have obtuse, one obtuse angle. You know what, I think I got the wrong cards out for this, but we'll work with it. And then an acute angle. Okay. I don't know if you remember this, but back in November, we talked about this and we said if they have, all they need is one right angle to be called a right triangle. All they need is one right, or whoops, not right, one obtuse angle to be an obtuse triangle. And how many acute angles do they need to be acute?
1, 2, 3. So all 3.
3 acute. I want everybody to take a look at your triangles. And I want you to just think about the size of the angles. Oh, I'm so sorry. Just look at the size of the angles. And I want you to turn and talk with your partner about if it is a right triangle, an obtuse triangle, or an acute triangle. Turn and talk.
Because it takes 3 minutes. Yeah, it's like this. Yes, it is. Acute. Acute. Okay, I thought that
One. But where do you see acute angles? Yeah. What's this angle right here? This one right here, this corner, this angle, and this angle. What's this one right here? Okay, what's this one?
Well, you can throw this one away because I just conjured. This is.
I don't know, we're gonna talk about it. Is this one kind of tricky to figure out?
No.
Well, let's take a look at them. Let's take a look at them. Who thinks they have a triangle that is acute? Acute. An acute means it has how many acute angles?
3.
3 acute angles. Who has? Okay, so let's take a look. Here are 2 examples right here. Everybody have your geoboards down and looking at these 2 examples. Do you agree that they're both? Okay. Do you guys agree that these are both acute triangles? Give me a thumb when you have some ideas. Are these both acute angles? Could you guys turn and talk about whether or not you agree or disagree with that? What? The evidence. Okay.
But it has to be 3 acute angles to be acute.
Okay, what do you guys think? What do you guys think? And let's go ahead and have your own triangles down, and you can call on each other, and we'll decide if you think both of these are acute. Either way that I hold it, it would still be the same, right? Even though you're kind of thinking about it like this. I'm going to hold it this way because it's easier. Brooklyn, why don't you call on somebody? Elizabeth, wait for everybody, please.
I don't think Brooklyn's is acute. I think it might be obtuse.
Okay.
I agree with Elizabeth. Because the bottom 2 angles, or bottom 2 are acute, and then the top is obtuse.
Obtuse. So you think, you guys are all agreeing that this one is acute?
Yes.
You guys agree that this one is acute? Okay, I'm just gonna put that one to the side. We're having a debate about this one. Brooklyn thinks this is acute. Some of you think it has an obtuse angle. Lonnie, go ahead. Wait, Daniela, wait for everybody.
I think it's a right angle because the way Brooklyn wanted to put it, it kind of looked like it was a right angle.
Oh, when you look at it this way, you feel like it looks more right? So if it's oriented this way, is it still right?
Yes.
How could we tell if it's right or not?
The corner of the paper.
Will you come do that for me, Jane? You know what, if you come behind me and do it behind the geoboard, it'll be easier because the pegs won't be in the way. Is it right?
Yeah.
Is it lined up?
Pretty much.
So it's a right angle. And I heard Brooklyn say, well, there's 2 acute angles. There's more acute angles than right angles. So why would it be called a right triangle? Go ahead and call on somebody, Jane. Neil, wait.
It would be a right angle because it has to have 3 acute angles to be an acute triangle. Because I don't know why, but an acute triangle would be an equilateral triangle, and an isosceles triangle would be a right triangle, or something like that.
Okay.
But her triangle
doesn't have 3 acute angles. Yeah.
I haven't had one, like, you can tell when it's a 90 degree, or you can tell when it's a right angle because it's at a 90-degree angle, like straight up. And obtuse is more like farther down.
A little bit bigger, yeah.
Yeah.
Okay, and this is still a little bit confusing. In Brooklyn, I heard you just say that it's a little bit confusing. So this is a little bit different than the lesson tomorrow, but we might have to do this with the rest of the class tomorrow too. Okay, so once we get to this point, then we're gonna start looking at different triangles and giving them 2 names. So we already named this triangle an isosceles, and now we're saying it's also a right triangle because it has one 90-degree angle, okay? But Brooklyn is saying it still has 2 acute angles. I'd like everybody to count how many acute angles you have on your triangle. Could everybody count how many? And then when you know, could you just hold them up? If you think you have 1 acute angle, then hold a 1 up. If you think you have 2 acute angles, hold a 2. If you think you have 3, hold a 3.
It's 100 cool.
Oh, yeah. Okay. All right. Erica, let me see yours. You're saying 1 acute angle. Everybody take a look at that. Where do you see 1 acute angle, hon? On the top, you're seeing this as acute. It's less than 90 degrees. Okay? Does anyone else see any more acute angles on this one? We're looking here, Jacob. Where do you see? Yeah. Jade.
I see them, like, it's all the corners. I see all of them acute.
So this looks acute to you, and this one looks acute, and this one looks acute. Anyone disagree with that? Yeah?
I disagree.
Oh, eyes over here.
Because I don't see this.
You don't see it as acute. Let's use a corner again. I like Jaden's little trick.
No.
Is it less than 90 degrees?
Yes.
Okay, so what kind of angle is that?
Acute.
Acute. So how many angles does this have? 3. Does anybody have a triangle with less than 2 right angles? Can you make a can you guys just go ahead and give it a try? I know we don't have too much time. I'd like everybody to try and make a triangle, 3 sides, with 2 right angles. Can you make a triangle with 2 right angles?
It's impossible.
Give it a try. Or 2 obtuse
I
angles.
just need a bit.
Oh, that's it. This is not a triangle. This is not a triangle. This is not a triangle.
You would get some.
When you think you know whether or not you can do it,
It's impossible. I just made a square.
ah. Okay, everybody give it a good solid effort.
This is what I created.
Does it have more than 1 right angle?
I made 1.
I made 2.
Is that a triangle?
Obtuse angle.
Okay, here's some shapes I'm seeing you guys make with 2 right angles.
Ta-da!
Let's take a look at these, everybody. Are these triangles?
No.
So is it possible to make a shape with 2 triangle with 2 right angles?
Impossible.
Impossible.
I made a big
Okay, we're gonna come back to this tomorrow. Go ahead and put your things away. Get ready for